Welcome to Tech with Kaushik. This is part 12 of our complete practice question series for the SAA-C03 AWS Certified Solutions Architect Associate exam. Choose your answer before the timer ends, then review the correct answer, explanation, and exam tip. Let us begin part 12. Question number 395. A global design marketplace stores project files in S3 buckets in US, West 2, EU, West 1, and AP, Southeast 2. Designers must upload to a nearby region, and customers must download from a nearby region through one application endpoint. Objects written through any region must become available from the other regions. The company wants the fewest application changes. Which combination of actions will meet these requirements? Choose 2. Option A. Create an S3 multi-region access point and update the application to use its ARN for both uploads and downloads. Option B. Configure one-way replication from the US, West 2 bucket to each of the other 2 buckets. Option C. Configure one-way replication from US, West 2 to EU, West 1, and then from EU, West 1 to AP, Southeast 2. Option D. Configure two-way replication rules so that objects written to any of the 3 buckets are synchronized with the other buckets. E. Use an S3 multi-region access point only for downloads and continue sending every upload to the US, West 2 bucket endpoint. The correct answer is A. Create an S3 multi-region access point and update the application to use its ARN for both uploads and downloads. D. Configure two-way replication rules so that objects written to any of the 3 buckets are synchronized with the other buckets. Here's why. The multi-region access point supplies one global endpoint and routes requests to a nearby bucket. Two-way replication keeps the writable regional buckets synchronized after uploads occur in any region. Why are the other options not correct? B. One-way replication from a single source does not synchronize objects uploaded into the other regional buckets. C. A chained one-way design does not provide full mutual synchronization among all writable buckets. E. Keeping all uploads on the original regional endpoint does not reduce upload latency for remote designers. Exam tip. For multi-region S3 reads and writes, combine a multi-region access point with two-way replication. Question number 396. A community media application lets users upload short-lived photos and clips. Most content is viewed immediately and 90% of views occur in the same geographic area where the content was created. The architecture should minimize upload latency and keep delivery close to the local audience. Which design provides the lowest upload latency? Option A. Send every upload through S3 transfer acceleration to a single bucket in one AWS region. Option B. Direct each user to an S3 bucket in the nearest AWS region and use separate CloudFront distributions with the corresponding regional buckets as origins. Option C. Upload files to EC2 instances in the nearest region and then copy the files from EC2 to Amazon S3. Option D. Use CloudFront to forward all uploads to one S3 bucket and store all content in that single region. The correct answer is B. Direct each user to an S3 bucket in the nearest AWS region and use separate CloudFront distributions with the corresponding regional buckets as origins. Here's why. Writing directly to the nearest regional S3 bucket minimizes the network distance for uploads. Regional placement also matches the strongly local consumption pattern, while CloudFront supports efficient delivery. Why are the other options not correct? A. Transfer acceleration can improve long-distance uploads, but still sends every object to one fixed region. C. An EC2 upload proxy adds another hop, scaling work, and a second transfer into S3. D. CloudFront does not select a nearest regional storage bucket when the origin is a single fixed bucket. Exam tip. When content is created and consumed locally, place writes in the nearest region instead of proxying them to one distant region. Question number 397. An insurance API receives claim events through Amazon API Gateway. Different Lambda functions should process only the event types relevant to them, and a single event can be delivered to several functions. The company wants a serverless routing service with content-based filtering and minimal infrastructure management. Which solution should be used? Option A. Publish events to Amazon SNS. Subscribe separate SQS and configure each Lambda function to pull its queue. Option B. Have API Gateway send each event to several SQS and configure Lambda event source mappings for the queues. Option C. Send the events to Amazon Event Bridge and create rules that invoke the appropriate Lambda targets. Option D. Publish the events to an Amazon MSK cluster and configure the Lambda functions as consumers. The correct answer is C. Send the events to Amazon Event Bridge and create rules that invoke the appropriate Lambda targets. Here's why. Event Bridge provides managed fan-out and content-based event pattern filtering, allowing each Lambda target to receive only matching events without queues or broker administration. Why are the other options not correct? A. SNS with SQS subscriptions can fan out and filter, but it adds queue resources and consumer configuration. B. The producer must implement fan-out and routing to multiple queues rather than using a central event router. D. MSK requires cluster capacity and broker operations that are unnecessary for this serverless use case. Exam tip. Choose Event Bridge when serverless consumers need content-based routing from a shared event stream. Question number 398. A research organization has millions of existing unencrypted objects in Amazon S3. Compliance requires the organization to encrypt both existing and future objects with a customer-managed AWS KMS key. The migration must be performed at scale with managed S3 capabilities. Which solution will meet these requirements? Option A. Use S3 storage lens to identify buckets, then configure SAA-C03 default encryption for future uploads only. Option B. Filter an S3 inventory report for unencrypted objects. Use S3 batch operations to copy those objects with SAA-C03 and configure bucket default encryption with the customer-managed KMS key. Option C. Filter an AWS usage report. Run an AWS batch compute job to rewrite the objects with SAA-C03 and configure SAA-C03 default encryption. Option D. Use S3 inventory and S3 batch operations to apply SAA-C to existing objects. Then configure SAA-C as the bucket default encryption method. The correct answer is B. Filter an S3 inventory report for unencrypted objects. Use S3 batch operations to copy those objects with SAA-C03 and configure bucket default encryption with the customer-managed KMS key. Here's why. S3 inventory supplies an object-level list. S3 batch operations can rewrite existing objects with SAA-C03, and bucket default encryption applies the customer-managed KMS key to future uploads. Why are the other options not correct? A. This protects future uploads, but does not encrypt the existing unencrypted objects. C. AWS usage reports are not an object inventory, and AWS batch adds unnecessary compute management. D. SAA-C must be supplied with individual requests and cannot be configured as S3 bucket default encryption. Exam tip. Use S3 inventory plus batch operations for bulk changes to existing objects and default encryption for future uploads. Question number 399. A public news website is hosted on AWS, but outages at its external authoritative DNS provider are making the site unreachable. The operations team has an export of the current DNS zone and needs to move authoritative public DNS to a resilient AWS managed service quickly. What should a solutions architect do? Option A. Create a Route 53 private hosted zone and import the exported DNS records. Option B. Create a Route 53 resolver inbound endpoint and configure the old provider to forward public queries to it. Option C. Deploy AWS directory service and configure a DNS zone transfer from the external provider. Option D. Create a Route 53 public hosted zone, import the zone file, and update the domain delegation to the Route 53 name servers. The correct answer is D. Create a Route 53 public hosted zone, import the zone file, and update the domain delegation to the Route 53 name servers. Here's why. A Route 53 public hosted zone is authoritative for Internet DNS. Importing the zone file recreates the records quickly, after which the registrar delegation can be changed to Route 53. Why are the other options not correct? A. A private hosted zone resolves only from associated VPCs and cannot serve the public website domain. B. Resolver inbound endpoints support hybrid DNS forwarding. They are not public authoritative DNS hosting. C. Directory service is not the managed public DNS migration service for an internet domain. Exam tip. Move public authoritative DNS to Route 53 by importing the zone records into a public hosted zone and updating delegation. Question number 400. A serverless order application needs a centrally managed feature settings and database connection credentials. Administrators want controlled configuration deployments and managed secret storage with the option to rotate credentials while avoiding custom storage code. Which solution has the least administrative overhead? Option A. Store encrypted configuration and credential files as separate objects in Amazon S3. Option B. Manage application settings with AWS App Config and store database and service credentials in AWS Secrets Manager. Option C. Use AWS Lambda as the configuration repository and store credentials in Systems Manager Parameter Store. Option D. Manage settings with AWS App Config and store the application credentials inside an Amazon RDS table. The correct answer is B. Manage application settings with AWS App Config and store database and service credentials in AWS Secrets Manager. Here's why. App Config provides managed configuration validation and deployment, while Secrets Manager securely stores and retrieves credentials and supports managed rotation workflows. Why are the other options not correct? A. S3 files require custom access, encryption, versioning, deployment, and secret handling logic. C. Lambda is compute rather than a configuration repository and would require custom persistence logic. D. Storing the credentials inside the database creates a circular dependency and is not a dedicated secret management design. Exam tip. Use AppConfig for deployable application settings and Secrets Manager when credentials require secure retrieval and rotation. Question number 401. A billing service connects to an Amazon RDS for MySQL instance. Storage encryption with AWS KMS is already enabled, but a security assessment found that client connections do not validate the database certificate or require encrypted transport. Which action will protect data in transit? Option A. Install the current AWS-provided RDS Certificate Authority bundle on the clients and configure every connection to require and validate TLS. Option B. Enable IAM database authentication and make no changes to the client transport settings. Option C. Restore the database from a snapshot into another encrypted RDS-DB instance. Option D. Generate self-signed certificates and configure the RDS-DB instance to use them for client connections. The correct answer is A. Install the current AWS-provided RDS Certificate Authority bundle on the clients and configure every connection to require and validate TLS. Here's why. The AWS RDS CA bundle lets clients validate the RDS server certificate, and requiring TLS encrypts the MySQL connection between the application and the database. Why are the other options not correct? B. IAM database authentication changes the authentication method, but does not by itself enforce TLS transport. C. Snapshot encryption protects data at rest and does not change network encryption. D. RDS uses the AWS managed certificate trust chain rather than customer-installed self-signed server certificates. Exam tip. For RDS encryption in transit, require TLS and validate the server using the current AWS RDS CA certificate bundle. Question number 402. A B2B API runs on EC2 instances across multiple availability zones. Partner networks will permit outbound connections only to IP addresses that have been added to their firewall allow lists. The service therefore needs highly available load balancing with stable public IP addresses. Which design meets this requirement? Option A. place the instances behind an application load balancer and assign an elastic IP address to the ALB. Option B, run a public EC2 proxy with one public IP address in front of an existing load balancer. Option C, use an internet-facing network load balancer and assign an elastic IP address to its subnet mapping in each enabled availability zone. Option D, create a Route 53A record that points directly to one elastic IP address. The correct answer is C. Use an internet-facing network load balancer and assign an elastic IP address to its subnet mapping in each enabled availability zone. Here's why. An internet-facing NLB can use a static elastic IP address for each enabled availability zone, giving partners stable addresses while retaining multi-availability zone load balancing. Why are the other options not correct? A. Customers cannot assign elastic IP addresses directly to application load balancer nodes. B. A single proxy adds server management and becomes a scaling and availability bottleneck. D. A DNS record pointing to one elastic IP does not provide a multi-availability zone load balance service. Exam tip. Use a network load balancer when external clients require static allow listed IP addresses. Question number 403. A startup has just created a standalone AWS account. The account owner wants to protect the root user before engineers begin deploying resources and ensure that root credentials are not used for routine administration. Which action follows AWS security best practices? Option A. Create root user access keys and use them for scripted daily administration. Option B. Create IAM identities for administrators and disable the AWS account root user. Option C. Give the root password to the lead architect and require that person to perform all administrative work. Option D. Enable multi-factor authentication for the root user and use appropriately privileged IAM identities for daily administration. The correct answer is D. Enable multi-factor authentication for the root user and use appropriately privileged IAM identities for daily administration. Here's why. MFA reduces the risk of root credential compromise, while daily work is performed with controlled IAM identities. Root should be reserved for the limited tasks that require it. Why are the other options not correct? A. Root access keys create high-risk long-term credentials and should not be used for routine work. B. The root user of a standalone AWS account cannot simply be disabled. C. Sharing and routinely using root credentials violates least privilege and credential management practices. Exam tip. Protect the root user with MFA, avoid root access keys, and use least privilege identities for normal administration. Question number 404. A scientific simulation uses a tightly coupled group of EC2 instances to exchange data continuously. The instances must achieve the lowest practical node-to-node latency and high network throughput inside one availability zone. Which two configurations should be used? Choose two. Option A. Select EBS-optimized instances to increase bandwidth between the compute nodes. Option B. Launch the instances in a cluster placement group. Option C. Attach several elastic network interfaces to every instance. Option D. Place the instances in separate AWS accounts to isolate network traffic. E. Use supported instance types and enable enhanced networking on every instance. The correct answer is B. Launch the instances in a cluster placement group. E. Use supported instance types and enable enhanced networking on every instance. Here's why. A cluster placement group locates instances close together for low latency, high throughput communication. Enhanced networking reduces virtualization overhead and improves packet performance. Why are the other options not correct? A. EBS optimization improves traffic between instances and EBS volumes, not inter-instance communication. C. Additional ENIs do not inherently lower the latency between nodes. D. Account separation is an administrative boundary and provides no network latency benefit. Exam tip. For tightly coupled EC2 workloads, combine a cluster placement group with enhanced networking. Question number 405. An engineering company is closing several offices and must migrate 120 terabytes of SMB file shares to AWS. The shares contain millions of small files, nested directories, and Windows file metadata. Existing applications must continue using SMB paths after migration, and the company wants a managed transfer and storage solution. Which approach has the least operational overhead? Option A. Use AWS Data Sync to transfer the SMB data into Amazon FSx for Windows File Server. Option B. Use AWS Direct Connect to copy the file shares into Amazon S3 and have the applications use S3 Object APIs. Option C. Use AWS Data Sync to migrate the shares into Amazon FSx for Lustre. Option D. Use AWS Direct Connect to migrate the data into an AWS Storage Gateway Volume Gateway. The correct answer is A. Use AWS Data Sync to transfer the SMB data into Amazon FSx for Windows File Server. Here's why. Data Sync is designed for managed transfer of large file datasets and supported metadata. FSx for Windows File Server provides managed SMB shares, allowing the applications to retain their file access model. Why are the other options not correct? B. S3 is object storage and would require the SMB applications to change their access method. C. FSx for Lustre targets high-performance POSIX workloads rather than managed Windows SMB shares. D. A volume gateway exposes ISCSI block volumes, not the required SMB file share interface. Exam tip. Use DataSync for managed SMB migration and FSx for Windows File Server when applications must keep SMB access. Question number 406. A company has dozens of workload accounts in AWS organizations and a dedicated observability account. Engineers in the observability account need to search logs, view metrics, and analyze traces from the workload accounts through CloudWatch without maintaining separate user credentials in every account. Which solution meets the requirement? Option A. Use service control policies at the organization root to grant the observability account access to all CloudWatch data. Option B. Create one IAM user in the observability account and attach policies from each workload account directly to that user. Option C. Configure CloudWatch cross-account observability with the observability account as the monitoring account and link the workload source accounts to its sink. Option D. Create IAM users in every workload account and configure cross-account policies for each monitoring engineer. The correct answer is C. Configure CloudWatch cross-account observability with the observability account as the monitoring account and link the workload source accounts to its sink. Here's why. CloudWatch cross-account observability shares supported metrics, logs, and traces from source accounts with a central monitoring account through managed syncs and links. Why are the other options not correct? A. SCPs set maximum permissions. They do not grant access or share observability telemetry. B. A policy in another account cannot be attached directly to a user in the monitoring account, and this does not configure data sharing. D. Per-account users increase credential risk and administration and still do not establish CloudWatch telemetry links. Exam tip. Use CloudWatch cross-account observability to centralize metrics, logs, and traces across AWS accounts. Question number 407. A ticketing website is delivered through CloudFront with an application load balancer and an EC2 auto-scaling group as the origin. AWS WAF is already associated with the distribution. Security logs identify a hostile public IP address that must be blocked before requests reach the origin. What should a solutions architect do? Option A. Add the address to an AWS WAF IP set and create a blocking rule in the web ACL associated with CloudFront. Option B. Add a deny entry for the address to a network ACL attached to the CloudFront distribution. Option C. Add a deny rule for the address to the security group of the EC2 instances. Option D. Add a subnet network ACL deny rule on the origin instances for the viewer IP address. The correct answer is A. Add the address to an AWS WAF IP set and create a blocking rule in the web ACL associated with CloudFront. Here's why. AWS WAF can match the viewer source address through an IP set and block the request at CloudFront before it reaches the ALB or EC2 instances. Why are the other options not correct? B. CloudFront distributions do not have network ACLs. C. Security groups contain allow rules and cannot express an explicit deny for one address. D. The origin network path is through CloudFront and the ALB, so blocking the viewer address at the outer web layer is the reliable design. Exam tip. Block known web client addresses with a WAF IP set at the outermost layer that receives viewer requests. Question number 408. A university manages 15 AWS accounts through AWS organizations and has several thousand staff members in an external identity provider. Staff should authenticate with existing corporate identities, and administrators need one place to assign groups to permission sets across the AWS accounts. Which solution should be implemented? Option A. Create IAM users in each required account and synchronize their passwords with the external identity provider. Option B. Connect AWS IAM Identity Center to the external identity provider, provision users and groups, and assign permission sets to the AWS accounts. Option C. Create root users for the staff and synchronize each root password from the identity provider. Option D. Use AWS Resource Access Manager to share the AWS accounts with identity provider groups. The correct answer is B. Connect AWS IAM Identity Center to the external identity provider, provision users and groups, and assign permission sets to the AWS accounts. Here's why. IAM Identity Center integrates workforce authentication with an external IDP and centrally assigns users or groups to multiple AWS accounts through permission sets. Why are the other options not correct? A. Creating IAM users in many accounts produces separate long-term identities and is not the intended federation model. C. Each account has one root user, which must not be used as a workforce identity. D. AWS RAM shares supported resources, not interactive workforce access to AWS accounts. Exam tip. Use IAM Identity Center with an external IDP for centralized workforce access across an AWS organization. Question number 409. A logistics company receives partner settlement files through SFTP and processes them once each night. The company is moving the workflow to AWS and wants highly available ingestion, durable storage, and a batch worker that runs only during the processing window. Operational effort must be minimized. Which architecture should be selected? Option A. Run an SFTP server on one EC2 instance, store files on an EBS volume, and keep one instance in an auto-scaling group. Option B. Use AWS Transfer Family for SFTP with Amazon EFS storage, and use scheduled EC2 auto-scaling for the nightly processor. Option C. Use AWS Transfer Family for SFTP with an Amazon S3 bucket, and use a scheduled EC2 auto-scaling group to process the objects each night. Option D. Run an SFTP server on one EC2 instance, store files on Amazon EFS, and keep one instance in an auto-scaling group. The correct answer is C. Use AWS Transfer Family for SFTP with an Amazon S3 bucket, and use a scheduled EC2 auto-scaling group to process the objects each night. Here's why. Transfer Family provides managed, highly available SFTP ingestion. S3 supplies durable serverless storage, and scheduled scaling runs the EC2 processor only during the known nightly window. Why are the other options not correct? A. A single self-managed SFTP server and its EBS volume create operational work and failure risks. B. EFS can work, but it adds a managed file system when durable S3 object storage is sufficient for the batch workflow. D. EFS improves storage availability, but the single self-managed SFTP server remains an operational burden. Exam tip. Use Transfer Family with S3 to replace self-managed SFTP ingestion, then schedule compute for predictable batch windows. Question number 410. A global financial portal runs HTTP applications behind load balancers in 3 AWS regions. Clients require fixed public IP addresses, Traffic should be routed to healthy low-latency regional endpoints, and the application must be protected from common Layer 7 web exploits. Which architecture satisfies all requirements? Option A. Place network load balancers in each region, associate AWS WAF with the NLBs, and register them with AWS Global Accelerator. Option B. Place application load balancers in each region. Use Route 53 latency routing through a CloudFront origin and associate AWS WAF with CloudFront. Option C. Place network load balancers in each region. Associate AWS WAF with the NLBs and use CloudFront with Route 53 latency routing. Option D. Place application load balancers in each region. Associate AWS WAF Web ACLs with the ALBs and register the ALBs as endpoints in AWS Global Accelerator. The correct answer is D. Place application load balancers in each region. Associate AWS WAF Web ACLs with the ALBs and register the ALBs as endpoints in AWS Global Accelerator. Here's why. ALBs support AWS WAF for Layer 7 filtering. Global Accelerator provides static anycast IP addresses and directs clients over the AWS network to healthy, performant regional ALB endpoints. Why are the other options not correct? A. AWS WAF cannot be associated with a network load balancer. B. CloudFront and latency routing can improve delivery, but this option does not provide the required fixed Global Accelerator IP addresses. C. NLBs do not support AWS WAF, and the design does not provide the stated static accelerator addresses. Exam tip. Combine Global Accelerator static IPs with regional ALBs and AWS WAF for protected global HTTP applications. Question number 411. A SaaS platform uses an Aurora MySQL cluster with readers in multiple availability zones. During traffic surges, applications open too many database connections. The company also wants client connections to recover more quickly when an Aurora reader is promoted to writer. Which solution requires the fewest application and database changes? Option A. Place Amazon RDS proxy between the applications and the Aurora cluster. Option B. Replace Aurora with DynamoDB and add DynamoDB accelerator for read traffic. Option C. Migrate the database to an RDS multi-availability zone DB cluster. Option D. Move the workload to Amazon Redshift and enable relocation. The correct answer is A. Place Amazon RDS proxy between the applications and the Aurora cluster. Here's why. RDS proxy pools and reuses database connections, reducing connection exhaustion. It also maintains application connectivity and avoids some DNS-related delay during Aurora failover. Why are the other options not correct? B. DynamoDB and DAX require a different data model and substantial application redesign. C. Changing database architecture does not directly address application connection churn and adds migration effort. D. Redshift is an analytical warehouse rather than a transactional replacement for Aurora MySQL. Exam tip. Use RDS proxy to absorb relational connection surges and improve application behavior during database failover. Question number 412. An AWS account that was already using S3 Object Lambda before November 7, 2025 stores customer support transcripts as S3 objects. An external auditor must select any transcript, including the most recent one, but must receive a version with personally identifiable information removed. The company wants request time transformation without maintaining a second copy of every transcript. Which solution has the least operational overhead? Option A. Run a scheduled EC2 batch process that redacts new transcripts and writes duplicate objects to another S3 bucket. Option B. Create an S3 object Lambda access point backed by a Lambda function that removes PI as each requested object is retrieved. Option C. Build an EC2 web application that lists objects, redacts each selected transcript, and serves a generated download. Option D. Invoke a Lambda function for every new S3 object and copy all non-PI fields into an Amazon DynamoDB table for the auditor. The correct answer is B. Create an S3 object Lambda access point backed by a Lambda function that removes PII as each requested object is retrieved. Here's why. For an eligible existing customer, S3 object Lambda can invoke Lambda during GetObject requests and return a redacted representation without creating and maintaining duplicate object sets. Why are the other options not correct? A. A recurring EC2 process adds server operations, delayed availability, and duplicate storage. C. A custom EC2 application requires scaling, patching, availability design, and ongoing maintenance. D. DynamoDB changes the access model and duplicates the transformed conversation data. Exam tip. For eligible existing accounts, S3 object Lambda can transform an object at retrieval time for a specific consumer. Question number 413. A retail company is moving an existing containerized service into a VPC that spans 3 availability zones. Tasks should be distributed across all 3 zones. Capacity should scale automatically with demand, and the company wants minimal application changes and operational overhead. Which solution has the least operational overhead? Option A. Run the service on Amazon EKS with self-managed EC2 worker nodes and configure target tracking with a minimum of 3 pods. Option B. Purchase 3 EC2 reserved instances, place them in a spread placement group, and use an auto-scaling group. Option C. Package the service as a Lambda function, register Lambda with application auto-scaling, and configure a minimum capacity of 3. Option D. Run an Amazon ECS service, configure target tracking with a minimum of 3 tasks, and use a spread placement strategy based on the availability zone attribute. The correct answer is D. Run an Amazon ECS service, configure target tracking with a minimum of 3 tasks, and use a spread placement strategy based on the availability zone attribute. Here's why. ECS runs the existing containers with less orchestration overhead than self-managed Kubernetes. Service auto-scaling adjusts task count, and availability zone spread placement distributes the minimum tasks across the 3 failure domains. Why are the other options not correct? A. Self-managed EKS worker nodes add Kubernetes and EC2 administration. B. Reserved instances are a pricing model, and a placement group cannot distribute one group across 3 availability zones. C. Lambda is not a drop-in platform for an unchanged long-running container service and is not scaled in this manner. Exam tip. Use ECS service placement across availability zones and target tracking for a resilient, elastic container service. Question number 414. A film archive stores 1 to 10 gigabytes S3 object for each title. Newer titles are requested frequently, while titles older than 20 years are requested rarely. After a purchase, playback must be able to begin within 5 minutes. The company must select the most cost-effective option from the choices below without violating the retrieval requirement. Which solution meets these requirements? Option A. Keep all titles in S3 standard and use lifecycle rules to move objects automatically when request demand falls. Option B. Store newer titles in S3 standard and older titles in S3 standard and frequent access, which provides immediate retrieval. Option C. Store newer titles in S3 intelligent tiering and older titles in S3 glacier flexible retrieval, using expedited retrieval after purchase. Option D. Store newer titles in S3 standard and older titles in S3 glacier flexible retrieval, using bulk retrieval after purchase. The correct answer is B. Store newer titles in S3 standard and older titles in S3 standard and frequent access, which provides immediate retrieval. Here's why. S3 standard IA lowers storage cost for rarely accessed older titles while retaining millisecond access, so multi-gigabyte video objects can be available within the 5-minute requirement. Why are the other options not correct? A. Lifecycle rules can use object age, prefix, size, or tags, but they do not detect falling request demand automatically. C. Expedited flexible retrieval is typically 1 to 5 minutes only for objects below the large object range. 1 to 10 gigabytes objects cannot be assured within 5 minutes. D. Bulk retrieval commonly takes hours and cannot satisfy the playback deadline. Exam tip. When an archive has a strict immediate access requirement, choose an online storage class rather than an asynchronous restore tier. Question number 415. A vendor supplies a batch utility as a Docker image. The container needs a mounted writable file system with at least 50 gigabytes available while it runs. The company requires serverless compute and does not want to administer EC2 container hosts. Which solution meets the requirements with the least operational overhead? Option A. Run the image as an Amazon ECS task on AWS Fargate and mount an Amazon EFS file system in the task definition. Option B. Run the image in AWS Lambda and mount an Amazon S3 bucket as a native writable file system volume. Option C. Run an Amazon ECS service with the EC2 launch type and attach an EBS volume larger than 50 gigabytes to the container instances. Option D. Run the image in AWS Lambda and attach an EBS volume larger than 50 gigabytes to the function. The correct answer is A. Run the image as an Amazon ECS task on AWS Fargate and mount an Amazon EFS file system in the task definition. Here's why. Fargate provides serverless container compute, and EFS provides a managed mounted file system with capacity beyond 50 gigabytes without provisioning container hosts or EBS attachments. Why are the other options not correct? B. Lambda does not mount S3 as a native general-purpose writable file system volume. C. The ECS EC2 launch type requires the company to provision, patch, and scale container instances. D. Lambda functions cannot attach EBS volumes. Exam tip. Use Fargate for serverless containers and EFS when a task requires a managed mounted file system. Question number 416. A company maintains business-critical EBS-backed AMIs for rapidly launching configured EC2 instances. Administrators want to manage safeguard that allows an accidentally deregistered AMI to be restored during a defined retention period without running periodic copy jobs. Which solution has the least operational overhead? Option A. Schedule periodic copies of every AMI into a second AWS account. Option B. Create an Amazon recycle bin retention rule that applies to the AMIs. Option C. Export the AMIs as ordinary objects to an S3 bucket and enable cross-region replication. Option D. Create separate EBS snapshots for every AMI and copy the snapshots to another account. The correct answer is B. Create an Amazon recycle bin retention rule that applies to the AMIs. Here's why. A recycle bin rule can retain matching deregistered EBS-backed AMIs and their associated snapshots, allowing restoration during the configured retention period without custom copy automation. Why are the other options not correct? A. Periodic AMI copies add storage, scheduling, and a recovery point gap between copy jobs. C. AMIs are not protected by uploading them as ordinary S3 objects and applying S3 replication. D. AMIs already reference EBS snapshots, and separately managing copies increases recovery work. Exam tip. Use recycle bin retention rules for fast recovery from accidental deletion of supported EBS snapshots and AMIs. Question number 417. A company that is an existing AWS Snowball Edge customer must migrate 150 terabytes of archived medical images to AWS within 30 days. Its WN permits only 100 megabits per second of migration traffic and is available for uploads during an 8-hour nightly window. The company wants the lowest cost option that can realistically meet the deadline. Which transfer method should be used? Option A. Enable S3 transfer acceleration and upload the archive through the existing WAN during the nightly window. Option B. Create a site-to-site VPN and an S3 gateway endpoint, then upload the data over the existing connection. Option C. Order multiple AWS Snowball Edge devices and transfer data with the devices in parallel. Option D. Use AWS Snowmobile to transport the archive to AWS. The correct answer is C. Order multiple AWS Snowball Edge devices and transfer data with the devices in parallel. Here's why. For an eligible existing customer, Parallel snowball edge devices avoid the insufficient one window and provide an economical offline transfer method for a 150 terabytes migration. Why are the other options not correct? A. Transfer acceleration cannot overcome the 100 megabits per second source bandwidth and limited nightly transfer window. B. A VPN and VPC endpoint change the network path, but do not increase available on-premises bandwidth. D. Snowmobile is designed for substantially larger, exabyte-scale migrations and is excessive for 150 terabytes. Exam tip. For eligible customers, Snowball suits tens or hundreds of terabytes when the available network cannot meet the deadline. Question number 418. A publisher is rehosting a 3-tier application on AWS. The internet-facing web tier and internal application tier currently run on third-party virtual machines, and the database is MySQL. The company wants minimal architectural change, managed point-in-time database recovery, and appropriate public and private subnet placement. Which solution has the least operational overhead? Option A, run both the web and application tiers on EC2 instances in private subnets and migrate the database to RDS for MySQL in private subnets. Option B, run the web tier in public subnets and the application tier in private subnets, and migrate the database to Aurora MySQL in private subnets. Option C, run the web and application tiers in public subnets and deploy Aurora MySQL in public subnets. Option D, run the web tier on EC2 instances in public subnets, the application tier on EC2 instances in private subnets, and RDS for MySQL in private subnets. The correct answer is D. Run the web tier on EC2 instances in public subnets, the application tier on EC2 instances in private subnets, and RDS for MySQL in private subnets. Here's why. EC2 preserves the VM-based tiers. The public web and private application placement follows the existing 3-tier access pattern, and RDS for MySQL adds managed operations and point-in-time recovery with minimal engine change. Why are the other options not correct? A. The option provides no stated public entry path for the internet-facing web tier. B. Aurora is MySQL compatible, but it introduces more database platform change than RDS for MySQL. C. Placing application and database tiers in public subnets unnecessarily exposes internal components. Exam tip. For a minimal change 3-tier migration, preserve tier isolation and choose the matching managed database engine. Question number 419. A supplier application in one AWS account must receive messages from an SQSQ owned by a separate partner account. The supplier wants to keep using IAM roles and permissions in its own account while being granted permission to pull only the partner queue. How should access be configured? Option A. Add a resource-based policy to the SQSQ that allows the supplier account's authorized principal to receive and delete messages. Option B. Create an EC2 instance profile in the queue owner's account and give it to the supplier. Option C. Create an SNS topic policy that grants the supplier access to the SQSQ. Option D. Create an identity policy in the queue owner's account and attach it directly to the supplier's external principal. The correct answer is A. Add a resource-based policy to the SQSQ that allows the supplier account's authorized principal to receive and delete messages. Here's why. An SQSQ policy is a resource-based policy that can grant a principal in another AWS account permission to pull the queue while that principal retains its own account identity. Why are the other options not correct? B. Instance profiles provide credentials to EC2 instances in the account where the profile exists. C. An SNS policy controls an SNS topic and cannot grant access to an SQSQ. D. An identity policy in the owner account cannot be attached directly to a principal owned by another account. Exam tip. Use an SQS resource policy for direct cross-account access to a queue. Question number 420. Administrators need audited shell access to Amazon Linux EC2 instances in private subnets. The instances have outbound access through a NAT gateway, but the company does not want public IP addresses, inbound port 22 rules, bastion servers, or separate VPN access for remote staff. Which solution is most cost-effective? Option A. Deploy a Bastion host in a public subnet. Restrict its security group to administrator source networks and manage SSH keys on the host. Option B. Attach an IAM role with Amazon SSM Managed Instance Core permissions to the instances and use AWS Systems Manager Session Manager. Option C. Create a site-to-site VPN for office users and require remote administrators to establish an additional VPN connection. Option D. Place a Bastion host in the private subnet. Grant EC2. Create VPN connection to administrators and install EC2 Instance Connect. The correct answer is B. Attach an IAM role with Amazon SSM Managed Instance Core permissions to the instances and use AWS Systems Manager Session Manager. Here's why. Session Manager uses the managed instance role and outbound connectivity to provide logged shell sessions without inbound SSH access, public addresses, bastions, or user-managed SSH keys. Why are the other options not correct? A. A public bastion adds EC2 cost, patching, key management, and an internet-facing attack surface. C. Site-to-site VPN connects networks rather than individual remote users and adds recurring infrastructure cost. D. A private bastion is not directly reachable from the administrators, and EC2. Create VPN connection is unrelated to host access. Exam tip. Use Session Manager for audited access to private EC2 instances without opening SSH or operating bastion hosts. Question number 421. A ticketing platform stores reservation state in an Amazon DynamoDB table. Operations staff must be able to restore the table to the exact state it had at any second during the previous 24 hours. The company wants a managed solution with no backup scheduling or custom recovery code. Which solution should a solutions architect recommend? Option A. Run a Lambda function every hour to create an on-demand table backup. Option B. Enable point-in-time recovery on the DynamoDB table. Option C. Enable DynamoDB streams and archive every stream record in Amazon S3 for later replay. Option D. Create an AWS backup plan that takes one DynamoDB backup each night. The correct answer is B. Enable point-in-time recovery on the DynamoDB table. Here's why. DynamoDB point-in-time recovery continuously protects the table and supports restoration to a selected second within the recovery window, directly covering the required 24-hour period without scheduled jobs. Why are the other options not correct? A. Hourly backups provide only hourly recovery points and require custom scheduling. C. Streams record changes but require a custom replay and reconstruction process. D. A nightly backup cannot restore the table to any second during the day. Exam tip. Use DynamoDB point-in-time recovery when continuous table-level restore points are required. Question number 422. A media laboratory has several on-premises applications that use block storage. Its dataset is growing rapidly, but researchers actively use only a small working set and need that working set at local storage latency. The organization wants the complete dataset stored durably in AWS so it can avoid purchasing additional storage arrays. Which hybrid storage design best meets these requirements? Option A. Deploy an AWS Storage Gateway Volume Gateway in cached volume mode and use Amazon S3 as the durable backing store. Option B. Schedule AWS data sync transfers from the storage arrays to Amazon S3. Option C. Mount an Amazon EFS file system across a site-to-site VPN and move all application data to EFS. Option D. Deploy an Amazon S3 file gateway and present the bucket through NFS or SMB. The correct answer is A. Deploy an AWS Storage Gateway Volume Gateway in cached volume mode and use Amazon S3 as the durable backing store. Here's why. A cached volume gateway keeps frequently accessed blocks in the local cache while storing the authoritative volume data in Amazon S3. This preserves block access and reduces the amount of on-premises capacity required. Why are the other options not correct? B. Data sync performs transfers but does not provide an active local block cache for the applications. C. EFS over AVP and does not retain hot blocks locally and changes the storage interface. D. S3 file gateway exposes file protocols rather than the block volumes used by the applications. Exam tip. Choose cached volumes when applications require local block access, but the full dataset should reside in Amazon S3. Question number 423. A document ingestion service writes uploaded PDFs directly to an Amazon S3 bucket. Each new object requires a metadata extraction task that completes in about 4 seconds. Upload traffic is unpredictable and can rise from a few objects per hour to hundreds at the same time. The company wants the lowest cost managed design. What should the solutions architect implement? Option A. Send CloudTrail data events to AWS AppSync and use AppSync to extract the metadata. Option B. Place Amazon Kinesis data streams in front of the bucket and invoke Lambda after records reach S3. Option C. Publish every upload to an SNS topic and use the topic itself to process the object. Option D. Configure an S3 object-created event notification to invoke an AWS Lambda function. The correct answer is D. Configure an S3 object-created event notification to invoke an AWS Lambda function. Here's why. Amazon S3 can invoke Lambda immediately after object creation. Lambda scales with concurrent events and charges only for the short processing time, avoiding continuously running infrastructure. Why are the other options not correct? A. CloudTrail is for auditing API activity, and AppSync is not an object processing service. B. Kinesis adds an unnecessary ingestion layer because the objects already arrive in S3. C. SNS can distribute notifications, but does not perform the metadata extraction and is unnecessary for one consumer. Exam tip. Use direct S3 event notifications with Lambda for short, bursty object processing tasks. Question number 424. A SaaS platform runs steady production workloads on both Amazon EC2 and AWS Lambda throughout the year. Its test account uses EC2 instances only from Monday through Friday during office hours, and the instances can be stopped at all other times. The company wants to minimize compute cost without committing to unused test capacity. Which purchasing strategy is most cost-effective? Option A. Purchase reserved instances for both production and test EC2 capacity, and stop test instances overnight. Option B. Use a compute savings plan for the steady production usage. Run test instances as on-demand and stop them outside office hours. Option C. Use dedicated hosts for production and an EC2 instance savings plan for the test account. Option D. Run production on on-demand instances and reserve dedicated hosts for weekend test work. The correct answer is B. Use a compute savings plan for the steady production usage. Run test instances as on-demand and stop them outside office hours. Here's why. A compute savings plan can discount the predictable EC2 and Lambda usage in production. On-demand pricing avoids a commitment for the intermittent test fleet, and stopping those instances removes compute charges when they are not needed. Why are the other options not correct? A. A commitment for intermittent test capacity can remain underutilized even when instances are stopped. C. Dedicated hosts add unnecessary cost, and an EC2 instance savings plan does not cover Lambda. D. On-demand production misses savings on steady usage, while dedicated hosts provide no benefit for idle test periods. Exam tip. Commit predictable multi-service compute usage to compute savings plans and keep intermittent environments stoppable and on-demand. Question number 425. A retailer is moving an on-premises Oracle database to Amazon Aurora PostgreSQL. Connectivity is already available through an AWS site-to-site VPN. The destination must receive the existing rows and remain synchronized with transactions that occur on Oracle until the final cutover. Which migration approach meets the requirement? Option A. Export the Oracle files with AWS DataSync, store them in S3, and import them with the Aurora AWS_S3 extension. Option B. Convert the schema with AWS SCT and run an AWS DMS full load-only task. Option C. Use AWS SCT for schema conversion and configure AWS DMS for a full load plus change data capture. Option D. Copy the database to S3 with a physical transfer device and import the exported files into Aurora. The correct answer is C. Use AWS SCT for schema conversion and configure AWS DMS for a full load plus change data capture. Here's why. AWS SCT converts schema objects between the heterogeneous database engines. An AWS DMS task configured for full load and ongoing replication loads existing data and applies source changes until cutover. Why are the other options not correct? A. Datasync transfers files and does not capture ongoing Oracle database changes. B. A full load-only task omits transactions committed after the load begins. D. An offline file transfer cannot provide continuous database change replication. Exam tip. For heterogeneous database moves, combine schema conversion with AWS DMS full load and CDC. Question number 426. A software company has several long-running Docker-based services. Each service must scale independently, and the company does not want to provision, patch, or scale container worker instances. Which two deployment choices satisfy these requirements? Option A. Run the services on Amazon EKS with self-managed EC2 worker nodes. Option B. Run the services on Amazon ECS with AWS Fargate. Option C. Package each service for Lambda and invoke it through API Gateway. Option D. Run the services on Amazon EKS with AWS Fargate. E. Run the services on Amazon ECS with EC2 container instances. The correct answer is B. Run the services on Amazon ECS with AWS Fargate. D. Run the services on Amazon EKS with AWS Fargate. Here's why. Both ECS with Fargate and EKS with Fargate provide managed orchestration, while Fargate supplies serverless compute. Individual services or pods can scale without a customer-managed EC2 worker fleet. Why are the other options not correct? A. EKS on EC2 requires management of the worker node infrastructure. C. Lambda is not a general replacement for long-running container services. E. ECS on EC2 still requires provisioning, patching, and scaling container instances. Exam tip. Use Fargate when container orchestration is required, but worker node administration is not. Question number 427. A concert ticket website runs on EC2 instances across multiple availability zones. Demand is normally modest, but can increase sharply when tickets are released. The company wants capacity to expand automatically without paying for peak capacity all month. Which design is most cost-effective? Option A. Create a launch template that uses a pre-built AMI and configure an EC2 auto-scaling group to add and remove instances according to demand. Option B. Keep the auto-scaling group's minimum capacity large enough for the release day peak. Option C. Maintain stopped instances and configure auto-scaling to restart those instances during a spike. Option D. Cache all dynamic transactions in CloudFront and Elastic Cache, then scale the origin down after the caches are populated. The correct answer is A. Create a launch template that uses a pre-built AMI and configure an EC2 auto-scaling group to add and remove instances according to demand. Here's why. An auto-scaling group can launch ready-to-serve instances from a pre-configured AMI as demand rises and terminate excess capacity after the spike, matching cost to actual traffic. Why are the other options not correct? B. A peak-sized minimum pays for unused capacity during normal periods. C. Auto-scaling launches instances from a launch template. It does not use a pool of stopped instances for scale-out. D. Ticket transactions are dynamic, and the proposed cache-heavy design does not replace elastic origin capacity. Exam tip. Use auto-scaling with a prepared AMI for sudden, temporary web demand. You have completed Part 12 of the SAA-C03 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.